Standard 9, but all of you can watch it. Standard 10 and even 11 can watch it and learn something from it, because sir is going to be here for next 45 minutes, and you can keep on sending your questions through our email, which is ciet.kishoremanch@gmail.com. You can even ask your questions through YouTube. Our channel is NCERT Official. You can write your questions in the conversation box and we'll receive it, and sir will definitely answer all your queries. You can also call us. Our numbers are 1800112199 and the other one is 1800111265. So we have got 2 toll-free numbers, and you're watching us on SWAYAM Prabha's channel number 31, Kishore Manch. Keep watching Kishore Manch, and let's begin with this maths class for now. I want to ask sir, what are we going to learn in this particular session?
Yeah. Thank you, madam, and welcome to all my viewers. Today we will start number system, as Tanvi has pointed out that it is the 4th video, number system. So we have discussed many things in number system in the earlier classes. Mainly what we have discussed in a quick view, that is first 3 videos we have discussed what is rational number, what is irrational number. So we have seen rational number is a number of the form p by q, where p and q are integers, q not equal to 0. And what is irrational number also we have seen. A number which is not rational is called irrational number, that we have seen. Then the collection of rational and irrational is real numbers, that we have seen. And then later we discussed about locating numbers on the number line. That is rational numbers and irrational numbers, locating them on number line, especially numbers like √2. Then we have studied that decimal expansions of real numbers. So we have studied some important features about decimal expansion of rational numbers and decimal expansion of irrational numbers. These are the things we have studied in the previous classes. So what we are going to discuss today is, I will just share some points. So mainly we are going to discuss about operations on real numbers. Second one is a process called rationalization, or method called rationalization of denominator. We want to rationalize the denominator. That is a very interesting method. We will see that one. Third one is laws of exponents for real numbers, because already laws of exponents students are familiar in class 8. They have studied that one. Now we are going to extend that definitions. These are the things we have going to start. So we will start with algebra of radicals. That means multiplication of numbers like √2 and √3 and other things. Okay.
Okay.
Start.
Okay. Yeah. So now that you've mentioned √2, √3, I want to ask, what's the meaning of square root of 2 times of square root of 3?
Yeah, that is very interesting thing which actually I want to discuss in detail. Okay.
Okay.
So what we will do is you are familiar with multiplication. Okay.
Yes.
Multiplication of numbers, almost everyone is familiar. From lower class itself you have studied multiplication of numbers. So you might have seen that multiplication of numbers when 2 times 3. When we studied in lower class, you might have seen that as repeated addition. Okay, you might have seen that one as a repeated addition. But at this, once we come for multiplication of rational numbers, the repeated addition will not work there. Suppose somebody asks you to tell what is 1 by 2 times 1 by 3. So you will be seeing that take a sheet of paper, fold it in such a way that there will be 3 equal parts, then divide into half. Then you will get that. Now the part which you are getting will be 1 by 6th of the whole paper, whole sheet of paper. So 1 by 2 times 1 by 3 is 1 by 6. That method you have studied. But these methods is not going to work in when you speak about irrational numbers, especially numbers like √2 and √3. This method may not work. So that is what we are going to see now. So for that one, what we want to know is, we want to know actually what do you mean by √2? What do you mean by √3? If you have watched the previous videos, we have seen some explanation for that kind of numbers, √2, √3, those numbers. So let me just quickly go back and show something which is required for today's discussion. Okay, so Suppose somebody says that root 2 is equal to 1.41421, etc. This approximate. Actually, what does it mean? We want to know what is the meaning of that one. So it means that you take a sequence 1, 1.4, 1.41, 1.4142, 1.41421 and square each term of that sequence. You can observe a beautiful thing here. You see 1 square is 1, 1.4 square 1.96, 1.41 square is 1.9881. Looking here, these numbers are coming closer and closer to 2. You can see 1.9, 1.98, 1.999, 1.9999 is coming to 2. So these squares are coming to 2 means the actual numbers will be coming closer to root 2. This is the idea in the decimal expansion. I think we have discussed in earlier videos also. So this is the meaning of root 2. Similarly, you can say what is root 3, what is pi, all these numbers. Now what I'm going to do is I'm going to extend this concept to multiplication of root 2 times root 3. So I want to see root 2 times root 3. So I'm going to make a table. Okay, you can observe the table here. The first column is x, second column is y, third column is xy, and the last column is xy whole square. So in the first column, I am going to write the expansion, decimal expansion of root 2, second column decimal expansion of root 3, and you can, third column you will multiply each x and y, then we'll observe what happens in the last column. You have to carefully observe what happens in the last column. So if it is 1, 1, xy is 1, xy square is 1. Next one is 1.4, 1.7, 2.38, 5.6644. As you proceed, you see last column, xy whole square, this column, this is coming closer and closer to 6. These numbers 5, 5.9, 5.99, 5.999, 5.9999, it is coming closer to 6. That means if these numbers are coming, these are squares of something. Squares are coming closer to 6 means these numbers will be coming to root of that one, root 6. That is root 2 times root 3 will be root 6. Okay. So this idea we can generalize in such a way that root of a times root b is equal to root of ab. Provided we should assume that not both of them are negative. Okay. If both of them are negative, we'll go end up in a new number system, which is complex numbers, which they are going to learn later, but we are not going to go to that direction. So anyway, you have to assume that both of them are not negative. So once this definition is once you have this root a times root b is equal to root ab, then immediately you can say root a, what is root a times root a whole square? It will be root of a square. So you are taking the square root and of a square, so you will get a. This you can check that one. Similarly, root a divided by root b will be root of a by b. These things will be there. Then applying the distributivity, and this previous one, distributivity, students are familiar with the, I think 6th standard, 7th standard, they are familiar with the distributivity and other things. So using this one, you will get root a plus root b times root c plus root d will be equal to root ac plus root ad plus root bc plus root bd. So these are, they can check very easily, no need to, it is not at all difficult. So now this is very useful one. You can see that root a plus root b times root a minus root b. It is looking like x plus y times x minus y, which is a familiar identity. So this will be of the form x square minus y square. So it will be root of a square minus root of b square, which will be a minus b. So interesting thing is this, there is a radical sign, root sign is here, there is a root sign here. In the answer, there is no root sign. So that is very important for us. We will see why it is important later. Another one is root a plus root b whole square is equal to whole square. If you take, it is already, you know that a plus b whole square. The same technique you are going to apply here, but whenever root a whole square is there, it will be a. So it will be a plus 2 root ab plus b. This is the some identities we can check. Different other identities are there. You can verify them very easily. So what we are going to do is we are going to apply some problems for that using that identities. Okay, shall we proceed? So
Okay.
these problems are very simple, not at all complicated. So 3 plus root 3 times 2 plus root 2. So what you are going to do is actually distributivity. This is the identity we are going to use here. You can check this identity also. So 3 plus root 3 times 2 plus root 2. If you use the distributivity, you have to multiply 3 times 2, then plus 3 times root 2, root 3 times 2, root 3 times root 2. Then you will get 6 plus 3 root 2 plus 2 root 3 plus root 6, which is a very simple calculation. There is nothing complicated here, very simple one. Okay, second problem, from observing here you can see something interesting thing. This is 3, here is also 3. This is root 3, this is root 3. What is the difference between them? There is here it is plus and here it is minus. So you can use this identity, a plus root b times a minus root b will be a square minus root b whole square. Root b whole square is b. So applying this one, you will get 3 square minus root 3 whole square, which is 9 minus 3, 6. Now third problem is also distributivity. 3 root 5 minus 5 root 2 times 4 root 5 plus 3 root 2. You have to multiply with 3 root 5 both terms, then minus 5 root 2 with both terms. Only you should be careful with the negative sign and other things. So, okay. So using distributivity, we are going to get the first time 3 times 4, 12, and root 5 times root 5 is 5 only. Similarly, 3 root 5 and 3 root 2. If you multiply, it will be 9 root 5 into root 2 is root 10. Minus 5 root 2 and 4 root 5 will give you a negative here, and 5 times 4 is 20 and root 10. Last one is minus 15 times 2. So you are going to get this answer as 30 minus 11 root 10. Okay. So now we are going to see that next our method called rationalizing the denominator. These are some, we are going to use the previous concepts now. What we have studied in the algebra, what we have studied there, we are going to see that concepts now. Now the question I want to ask you is, can we locate 1 by root 2 on number line? You people are familiar with root 2 and locating the numbers on number line. Last video when Dr. Patanjali was discussing, he was telling how to mark numbers, real numbers on number line, and there was a discussion. From the second video, third video, we have discussed marking root 2 on number line in a detail. So here the question is how to mark 1 by root 2 on number line. Okay, so if it is 1 by 2, it was very easy to locate, because you take the number line, mark the point 1, then take the half of it, then you will get 1 by 2. Okay, if it is root 2, you have a method. The method is you will take complete a right angle triangle with base 1, altitude 1, then draw an arc and mark it on the number line. That root 2 can be marked in that way, 1 by 2 can be marked, but here the question is 1 by root 2. So this you cannot apply this previous method. So we'll see what we can do. Okay.
So before we go further, we have a question by one of the viewers.
Yeah.
The viewer wants to know, every irrational number is a real number?
Yes, every irrational number is actually that the collection of numbers consisting rational numbers and irrational numbers together is called real number. So if you pick a real number, it will be either a rational number or an irrational number. That is, any irrational number is a real number.
Oh.
I think it is clear. Okay.
Yes, sir.
So we will go for the locating 1 by root 2 on the number line. What method we can apply? Let us see. So 1 by root 2, I am going to multiply with 1. It will not going to change if you multiply something with 1. But this 1, I am going to write it as root 2 divided by root 2. Okay. So once I multiply this with root 2 divided by root 2, numerator will be 1 times root 2, denominator will be root 2 times root 2. Root 2 times root 2 is root 2 whole square, which is 2. So what you obtained is 1 by root 2 is equal to root 2 by 2. Now this is very easy to locate, because what you do, you know how to locate root 2. From origin to root 2 you mark, then take its half of it. So you can mark that on the number line. Okay, now while looking here, there is one interesting feature here. In the starting, the denominator was an irrational number. Okay, the denominator was an irrational number, but in the right hand side, it is equal to a number root 2 by 2. Here the denominator is a rational number. Okay, that is our key step. So what we have made here, denominator is an irrational number, we convert into a denominator into rational number. So that is the process called rationalizing the denominator. So we say that suppose a number is of the form p by q, where q, the denominator, is irrational. The process of converting that denominator q into a rational number is called the rationalization of the denominator. So this is a process. Different problems we can see in that one. Okay, I think it is clear.
Sir, we have a question. Yes,
Yeah.
we have a question. So the viewer is asking how to locate root 9.5 on the number line.
Exact root 9.5 they're asking.
Yes, sir.
Actually, that each number, I don't know why they are particular about 9.5. There are different methods. One is the triangle, completing the triangle method. Okay, so that we have the process, but exactly one particular number, root of 9.5, if you want to do that one method you can do is completing the triangle only, that method, but you should be little careful here. Otherwise, the second method is approximate method. You can find the decimal values and try to locate that one. That is the method we can adopt. Okay. So, shall we proceed?
Yes, sir, please.
Yeah. So, we'll go for some problems based on rationalizing the denominator. So, the first problem is 1 divided by 2 plus root 3. Okay. So, how to do that one? So, look to this particular problem, 1 divided by 2 plus root 3. So 1 divided by 2 plus root 3, the denominator is irrational number. 2 plus root 3 is an irrational number. I want to make that one a rational number. That is the process rationalization of denominator. So what I am going to look into, I want to get rid of my root 3 and make it some rational number. Okay. So what I will do is, I know different identities. Among them, one identity is very useful, which is a plus b into a minus b. Okay, so what I will do is I will multiply both numerator and denominator with the 2 minus root 3. So it is multiplying with 1, because numerator and denominator is same. So 2 minus root 3 and 2 minus root 3, I am multiplying both numerator and denominator with 1. Okay, so once you multiply, numerator is not going to have any effect here, 2 minus root 3 only, but denominator, it is of the form a plus b and a minus b. It will be a square minus b square. A square means 2 square, which is 4, minus b square is root 3 whole square, which is 3. So denominator will be 4 minus 3. So what happens is the answer will be 2 minus root 3. So your denominator now become 1, which is a rational number. So this is the process called rationalizing the denominator. Okay. So only what we should be very careful about choosing your multiplying thing. 2 plus root 3 is here, so I multiply with 2 minus root 3 in the both numerator and denominator. Okay, we go for another problem. So this problem, we are asking to find the value of a if 3 minus root 5 whole divided by 3 plus 2 root 5 is equal to a root 5 minus 19 by 11. Okay. So what we are going to do is, we are going to take 3 minus root 5 whole divided by 3 plus 2 root 5 and multiply. Now this is here the denominator is irrational number. So I want to rationalize that one. I want to rationalize the denominator. what I am going to do is I am going to multiply both numerator and denominator with 3 minus 2 root 5. You can easily identify how I am choosing that number. Here it is 3 plus 2 root 5. So I am multiplying with 3 minus 2 root 5. Then only I can apply in the denominator a square minus b square. So if you apply that one, you will get numerator, it is 3 minus root 5 times 3 minus 2 root 5, which is a normal distributive law multiplication. Denominator will be 3 square minus 2 root 5 whole square. It is 2 square is 4, root 5 square is 5. So by simplifying that one, actually there will be a negative sign will come, you have to adjust with that one. Then once you simplify, you will get 9 root 5 minus 19 whole divided by 11. So 3 minus root 5 whole divided by 3 plus 2 root 5, you can write as 9 root 5 by 11 minus 19 divided by 11. So our question was to find a such that 3 minus root 5 whole divided by 3 plus 2 root 5 is equal to a root 5 minus 19 by 11. But we have simplified the left hand side and told that this is 9 root 5 by 11 minus 19 by 11. So we want to find a in such a way this equation is satisfied. So this equation will be satisfied by simplifying this one. You will get a equal to 9 divided by 11. So this is the use of rationalizing the denominator in the many type of problems. Many other problems are in the book. They can try those problems. Now we are going to the third part of our discussion, which is laws of exponents of real numbers. That is what we want to do is we want to extend our laws of exponents. Okay. So from lower classes, students have studied about laws of exponents. Laws of exponents when a, m, n all are natural numbers. You know many properties. What is a raised to m times a raised to n? What is a raised to m whole raised to n? What is a raised to m divided by a raised to n? All these things they have already studied. Now, but we have studied in such a way that our exponents, that n and m, are natural numbers.
Right.
So what we want to do is now we want to extend this into rational numbers. That I want my exponents to be rational numbers. How I am going to do that one, you can see. So first what I will do is I will extend these definitions of exponents, of laws of exponents of natural numbers to integers first. Then I will go for rational numbers. Let us see how I am going to do that one. Okay, so these are the laws of exponents which you have already know. A, n, m are natural numbers. A to the power m, a to the power n is a to the power m plus n, a to the power m whole power n is equal to a to the power mn. A to the power m divided by a to the power n is equal to a to the power m minus n. Here you should be very careful. This definition is valid only when m is greater than n. Okay. So a to the power m, b to the power m is equal to ab whole power m. Here we will call a as base and m and n are exponents. So keeping this, what we will do is we will define for any real number a to the power 0 is equal to 1. So we are going to define that one. Okay. Then next one is a notation. When we have 1 by a, we will denote it by a to the power minus 1. 1 by a is denoted by a to the power minus 1. Then we can say that 1 by a to the power n equal to a to the power minus n. So once n is a natural number, minus n is a integer. Okay, so what we have done, we have extended our exponents to integers now. From natural numbers, we have moved to integers. Okay, now what we want to do next is, I want to continue this 1 to rational numbers. I want to do this extension to the natural. From natural numbers, we are in integers. Now I want to go to from integers to rational numbers. So you can see how I am going to do. Before that, what I want to do is, I want to, already in 8th standard, most of the students have studied about square, square root, cube, cube roots. All these things you have already studied. So if somebody asks, what is the cube root of 8? You know the answer. I'm not asking the answer. What does it mean? somebody asks you what is cube root of 8, it means that do you know some number b such that b cube equal to 8? That is the actual question. If somebody asks you cube root of 8, the question is, can you find a number b such that b cube equal to 8? So you know that 2 cube equal to 8. So cube root of 8 is equal to 2. That already you know. Okay. Similarly, if somebody asks what is the fifth root of 243, the question is, can you find some number b such that b raised to 5 is 243? So the answer will be 3. So fifth root of 243 will be 3. So what we are going to do now is we are going to define the nth root now. Let us see the definition. Okay.
So we are receiving a lot of questions here.
Yeah.
I'm going to ask a few. So just when you were describing exponents of law, the question was, what if n is greater than m?
Actually, it is not defined in the natural number case. Actually, now we have, actually since the question comes little late, now I can say what is that one. Because starting, the a to the power m divided by a to the power n is defined equal to a to the power m minus n. You can define only when m is greater than n. That was in the up to 8th standard what we have done. Now we want to define for the cases whenever m is less than n also I want to define. Now I have defined m. For example, if you write a cube by a raised to 4. Okay, if somebody is writing as a cube divided by a raised to 4, now it will be a to the power minus 1. Okay, this is possible only if you extend your definition. Mathematics, many times what we will do is we do extend our definitions, which we have studied in the lower classes. That is very simple thing. Suppose usually we will tell, suppose you go to a very preschool child studying in our viewers, younger brothers or sisters will be there. You show them some toffee, 5 toffees you show them, and ask them that take 8 toffees from that one. They will tell it is not possible. For a class 1 student, it is not possible. But if I ask for a 8th standard student, 5 minus 8, they will quickly tell that it is negative number. Answer will be a negative number. Like that, we are extending our definition. So that is what we have done here. We have actually extended our 8th standard laws of exponents to, it was for natural numbers. Now we are on integers because we are working on number system. So if you remember the number system, integer means natural number, whole number, then integer, then rational, then irrational. It was going like that. So this is what we have done there also. We are already in 8th standard. We have a definition. That definition I have state as it is. I did not do anything. Now I extend that to integers. So now they can do what is, even though m is less than n, they can do the problem. Or they can see what it comes. Okay.
So,
now we will,
yeah, there's one more question.
Yeah.
Although there are a lot of questions, I'm going to ask a few. So how to locate 3 root 7 on number line?
Yeah, these questions actually, it will take little time to calculate. That is the only thing I want to tell, because we want to, locating the numbers is actually one method is what we told is completing the triangle. You have to find the 3 root 7's whole square. Okay. And can you write this as sum of 2 other numbers and applying the Pythagoras law? That is the main idea for us. Always we are trying to use Pythagorean triangle, that right angle triangle method. So what we want, whether it is 9.5, root of 9.5 or 3 root 7, the first thing what we are going to do is we are squaring that one. And that should be our hypotenuse. Then you have to choose your base and altitude in a suitable way. You have to choose, if it is 3 root 7 means 9 times 7, 63. So what I should do is I have to split my 63 in suitable way. If it is very helpful, if I can split it into sum of 2 perfect squares, say a square and b square, then I will take a unit on the base and draw a perpendicular of b unit. Then always it will be c. The diagonal will be c. Okay, that is the method you are going to use. So almost all the problem, your job is to find base, suitable base and suitable altitude. Okay, so you can ask different questions. Suppose generally I will try to answer that one. If somebody asks you to find locate C, whether it is rational number or irrational number. If somebody asks you to locate C, the method, what I am going to suggest is a general method. You just take C square, write C square as sum A square plus B square, then find a triangle with base A and altitude B, then the hypotenuse will be C, complete that one. That is a general method. You can try that one with different numbers. One by one, if somebody asks questions, can you locate 2, can you locate 3, can you locate root 3, root 7, almost all this is a general method, but that takes little time. You have to choose your 63, you have to split in such a way that you have to choose. Okay.
Okay.
Yeah. Shall we proceed?
Yes, sir, please.
Now what I am going to do is, I'm going to say what is nth root. Okay. Nth root we will define as, let A be greater than 0 be a real number, n be a positive integer. Then nth root of A equal to B if B to the power n equal to A and B greater than 0. So if somebody asks what is nth root of A, the job is to find a positive number B such that B to the power n equal to A. That is called nth root of A. Okay. So we have come to nth root. From square root, from cube root, we have come to any nth root where n is a positive integer. That means n is a natural number. Okay. Now, what I am going to bring a notation here, that notation is nth root of A, you will denote it as A to the power 1 by n. When I am asking you to find nth root of A, it is a notation. It will be denoted by A to the power 1 by n. So if you remember the laws of exponents, what we have started is from natural number, then you go for whole numbers. When A to the power n is a whole number, then whole A to the power n, when n is an integer we have defined so far. Now what I have done is I have defined for unit fractions. Unit fraction is a fraction of the form 1 by n. Okay, so I have defined for a unit fraction. Now I am going to extend this definition for all rational numbers. So for that one, if somebody asks you to find A to the power 2 by n, what I will do is I will find A to the power 1 by n, which is already defined, and whole square. It's square. So it will be nth root of A square. So are you clear with that one? If somebody asks A to the power 2 by n, then I will take A to the power 1 by n whole square. And that means nth root of A square. So if somebody asks A to the power m by n is a rational number. So if somebody asks A to the power m by n, what I should do is I will take A to the power 1 by n whole to the power m, which is nth root of A whole to the power m. So this is the method. Now my laws of exponents are defined for, means exponents are defined for rational numbers also. Okay. So if somebody asks what is cube root of 2, it is 2 to the power 1 by 3. It is only a notation. Fifth root of 32 is 32 to the power 1 by 5. So what is your job? You have to find a number B such that its fifth power is 32. The answer will be 2. If somebody asks fourth root of 625, the answer will be, it will be denoted by 625 to the power 1 by 4, which answer is 5. Then 1 by 8 raised to 1 by 3. Here you have to do some small work. So 1 to the power 1 by 3 and 8 to the power divided by 8 to the power 1 by 3 I will write. So it will be 1 to the power 1 by 3 is 1 only. 1 divided by 8 to the power 1 by 3 will be there. That is, denominator is, you have to find the cube root of 8, which we already know it is 2. So this is the one. Next one is 4 to the power 3 by 2. There are two methods. One method I am explaining now. Another method is in the textbook. They can see that one. 4 to the power 3 by 2. It is 4 to the power 1 by 2 cube. 4 to the power 1 by 2 is square root of 4 whole cube. So square root of 4 is 2. 2 cube is 8. That is 4 to the power 3 by 2 is 8. So with that one, we are extending our laws of exponents for rational numbers. So these laws are very easy. When A is a non-negative, means positive real number, then p and q be rational numbers, then a to the power p times a to the power q is equal to a to the power p plus q, a to the power p whole power q is a to the power pq, a to the power p divided by a to the power q is equal to a to the power p minus q, a to the power p b to the power p is equal to ab whole raised to p. So we need not worry about whether p is great in this third one. We need not worry about whether p is greater than q or those things, because all these things we have now defined. We have extended our definition. Actually, if you do not use those notations, okay, so I have used some notations for doing that one. If I do not use these notations, then this writing will be little tedious. You have to write many cases. You have to split into when it is positive, when it is negative, all these things you have to write. That is why we use that notations. So I think with that one, we can go for some problems based on this. Okay.
So we have a lot of questions coming in, but because of the lack of time, we won't be able to take all. But I want to ask one of them. So the viewer is asking, how can we find square or cube root of any number without using the Pythagoras theorem?
Which one? That are they asking the computation problem? That calculation problem means there are methods are there. There is standard methods to find the square root of this one. Another one is an algebraic method is there. I think that will take time. I think we have to discuss it in a very detailed video where we have to discuss in detail. That means how to do that one, x cube equal to some number, solve that equation. That method is little tedious. Square root is also actually solve a quadratic equation. Those methods are there. I think in higher classes they are going to learn that one. So without taking the Pythagoras, this one, that is actually to locate. I told not to find the value. I give that method to locate them on number line, that Pythagoras theorem, that right angle triangle method. If somebody is asking how to find, there is a computation methods are there. Typical computation methods are there, which they may be learning in the higher class also. Algebraic methods, they will surely algebraic methods they will learn in higher classes. Okay. So shall we go for problems?
Yes, sir.
So one is the first one or two problems are very easy. So 2 to the power 2 by 3, 2 to the power 1 by 3 you want to find. So it is very easy to solve that one. Just apply the law. There is nothing to do that one. Second one is also, it is going to give you answer 2 to the power 2 by 3 plus 1 by 3. So answer you will get very easily. Because of time constraint, I am not going to solve this now immediately. Second one is also very easy one, 125 raised to minus 1 by 3. Whenever negative is there, bring it down. That is 1 divided by 125 raised to 1 by 3 will come, and you can solve that one. Third problem is little interesting. That is why I'm keeping this problem. Just 1 minute I will take for that one. This calculation is very simple for everyone.
Okay.
1 cube is 1, 2 cube is 8, 3 cube is 27. Add them, you will get 36. 36 raised to 1 by 2 is 6. So answer you will get. Very easily you will get answer. But my question for my viewers is, what happens if you start 1 cube plus 2 cube plus 3 cube plus 4 cube and raise to 1 by 2? What will happen? 1 cube plus 2 cube plus 3 cube plus 4 cube plus 5 cube raised to 1 by 2. What will happen? Can you identify some pattern there? Do you have some particular type of pattern in that one? Can you see some features there? If somebody directly asks you, what is 1 cube plus 2 cube plus 1 cube plus 2 cube plus 3 cube, etc. plus 100 cube, whole raised to 1 by 2. What will be that one? Can you find that one? That problem is a little interesting. They can try themselves for that one. So we will go for the next problem.
Sir, we don't have any time left.
These
for
two
now.
problems, just they can see that one. These two problems, they can see these two are very interesting problems and they can solve it themselves. Okay.
Sure, sir. Now that you have shown it to them, I'm sure they'll solve it.
So these are the things we have studied in the number system unit, rational numbers and all these things we have discussed. Today also we have come across something, and I think we don't have much time to do that one. So we will conclude.
Thank you, sir. It was a very interesting session. Like I said, maths is always interesting, and there were many questions related to your topic, and people were asking so many things, although it takes time to locate and solve everything. So maybe you can take another session only
Yeah.
to take viewers'
For solving
questions.
these problems, yeah, that we can think.
Yes.
We can say, if the problems are given to me, that what are the problems you can give to me, then we can solve those problems and have a session on solving those
Sure,
their
sir.
doubts only. Okay. Thank
Thank
you,
you so
Melody.
much
Thank you.
for being here.
Thank you.
Don't go anywhere because we're coming back in a short while with another topic on English, which is going to be nouns and types of nouns. So stay with me, stay protected, and yes, keep on watching NCERT's online resource material. Thank you so much.